because I want to share with you some of our latest work. Now, I'm going to not commit the world's most famous mistake, which is somebody dealing with technology showing you a piece of software that is not finished, that is full of bugs. I know that if I showed it to you, every single bug that exists in the software would immediately become evident to you. So this is not going to be very slick, but I want to just share with you a piece of work that we're doing at the moment. And I'm going to try and save some time by not showing you everything. So this is a project that is about something very specific, and it's an example from mathematics, but don't worry, as I said, it's very, very simple mathematics. And we think that there's an issue here that we wanted to address, and the issue is this. We want kids to understand that maths and science is about generality. And yet, a good way to understand generality seems to be to think about special cases. For example, have we got technology that lets me draw on something? Oh, never mind, doesn't matter. If I say to kids, here's a sequence of numbers, 1, 4, 7, 10, 13, 16. And I say to kids, what's the next number? They all know. If I say to them, what's the 10th number? What about the 10th number along? They all count. And some of them count 9, and some of them count 11, and some of them get the adding on 3 wrong. But mostly the kids know. But if you say to the kids, what's the nth number in the sequence? That's a really hard problem for many kids. Okay, I'm sure it's not a hard problem for you here, but it is a really hard problem. And in fact, I'll give you a really surprising piece of data. Supposing I ask kids this. This is a really classic question in the UK national curriculum. So you make a little row of tiles, and then you surround the tiles with, I think they're originally red actually, I don't know. And you say, how many tiles are there around? So you're all, okay, can you put your hand up if you're counting? Right, so nobody here was counting. But I promise you, all the kids count. They say, well, there's 5. No, but there's 6, is it? 6. So there's 1, 2, 3, 4, 5, 6, and another 6, and so on. And the kids count. And it doesn't matter what you do, the kids will always try to count. And here's a nice example. If you say to them, for 6 white tiles you need 18 grey tiles. And then you say to the kids, I'm talking about kids aged around 14. Now let's see if this works in Hong Kong. What would the kid typically say if you had 60? Right, you don't have to shout it out. Have you all got an answer? Do you understand what the problem is? What would your kids say? What would an average 14-year-old kid say if you said 6 tiles makes 18 reds, greys, so 60 white ones would be how many? Okay? Oh, and the answer is it's got wiped out. So a lot of kids say 120. You know why this? Sorry, 180. I mean, 180. And because 6 threes are 18, so 60 times 6. And some people, there's all sorts of answers, none of which are right. Because what happens is the kids are not looking at the structure of the problem and saying, well, there's lots of different ways we could look at it. We could say it's the number of white tiles above plus the number of white tiles below, and then 3 here and 3 here. That's one way you could look at it. Or you could say it's the white tiles plus 2 across the top, and again across the bottom, and then 2 left over. There's lots of different ways of thinking about it. But what we find very, very difficult in the UK, but no, I know this is true all over the world, it's even true in Sweden, the kids find it very hard to not to learn how to solve problems like this. That's not so difficult. The problem is they don't see the point. What is this funny subject called mathematics, where you have to keep your eye on what's happening in the general case? But the teacher's asking me, how many red tiles are there? So I'll count them. If you say there are 6 whites, how many reds? I don't know, I'm going to count them. And if you say 60, well, I'll count them, but it'll take me a little time. Okay, so here's an example of what kids do. You say to them, write down the number of squares in each term. How many are there needed for the 10th? How many are for the 50th? Show you're working out. Always has to say, show you're working out. I'm sure that's true in every country. And here's what kids do. You see the top kid says 5, 7, 9, 11. So for 10th term we need 10 times 5, which is wrong, but it's a very heavy temptation. And for the 50th term we need 50 times 5. And then the other kid does something a bit different and so on.